Hello guys, hope you all are doing well. So, in the continuation of the previous GATE series, uh, we are solving the questions of GATE 1990, and today we will complete 1997. Okay, so without wasting time, we will just look into the question. Ethanol is manufactured by the vapor phase hydration of ethylene according to the reaction C2H4 H2O that gives C2H5OH. Okay, the reactor operate at 400 Kelvin and 2 bar pressure, and feed is a gas mixture of ethylene and steam in a mole ratio of 1:3. Okay, so 1 mole of ethylene and 3 mole of water. Equilibrium constant is 0.5. So they have given the equilibrium constant directly. No need to find it. Okay. Estimate the composition of the equilibrium mixture. Okay. So very first we have C2H4 plus H2O that gives C2H5OH. Okay. At T equal to 0, this is 1 mole, this is 3 mole, this is 0. At T, at some time when the reaction started, this is E, this is 3 minus 1E, 1 is the mole, so E, and 1 minus 1E, 1 is the stoichiometric coefficient C2H4. Okay. Now, moles at equilibrium is equal to 1 minus E. After completion of the reaction, this will be the product 1 minus E plus 3 minus E plus E. So E and we consider, so it will give 4 minus E. Okay. Now we know that Kp is equal to Ky e to the power summation of nu, where nu is the stoichiometric summation of stoichiometric number. So 1 stoichiometric coefficient of C2H5OH, positive for the product, negative for the reactant. So it will give minus 1. Okay, so Kp is 0.5 directly given. Ky. So for C2H5OH, for product, E upon 4 minus E divided by, for reactant, 3 minus E upon 4 minus E into 1 minus E upon 4 minus E. P is 2 bar to the power minus 1. Okay, so when you will solve this, you will get a quadratic equation. Suppose I will solve one more step. E 4 minus E. Okay, this will give 3 minus E. This will give 1 minus E upon 4 minus E square. The square will go out. This will cut. Okay, so E 4 minus E upon 3 minus E 1 minus E. After solving this, and don't forget 1 by 2. Okay, so into 1 by 2. So it will give 1 equal to E 4 minus E 3 minus E 1 minus E. So you will get a quadratic equation 2E square minus 8E plus 3 is equal to 0. Apply quadratic formula, so you will get E is equal to 0.42. Now 0.42 moles C2H5OH is produced. 3 minus E, H2O left, 1 minus E, C2H4 left. So that is the equilibrium mole composition in moles. Okay. If you want to find out the mole fraction, then this for C2H5OH, the mole fraction is E upon 4 minus E. Moles at the equilibrium upon total moles. Okay, so if you have any kind of doubt in this question, just comment it below. Okay, we will go a little bit fast, because if we will go slowly, then video will be long. In a double pipe heat exchanger, hot water flows at a rate of 50,000 kg per hour and get cooled from 95 degrees Celsius to 65 degrees Celsius. At the same time, 50,000 kg per hour of cooling water at 30 degrees enters the heat exchanger. Flow conditions are such that the overall heat transfer coefficient remain constant at 2270. Determine the heat transfer area and the effectiveness of the heat exchanger. Assuming parallel flow and both the streams has CPs. Okay, so very first thing, it is a parallel flow. So we know that for parallel flow, this is the temperature profile. From 95 degrees Celsius, hot water is cooling up to 65 degrees Celsius, and cold water is entering at 30 degrees Celsius, and we need to find this T. Okay, so mCp delta T of hot heat lost by the hot fluid, mCp delta T hot gained by the cold fluid is equal to UA theta m. Okay, so since mCp of hot fluid is equal to mCp of cold fluid. Okay, so 95 minus 65 is equal to T2 minus 30. T2. Okay, so T2 is equal to 9550 9 30 30 plus 30 60 60 degrees Celsius. So T2 is 60 degrees Celsius. Now finding theta m. So this minus this, then 95 minus 30 65. This is 60. 65 minus 60, that is 5. 65 divided by 5, 5 and 5, 5 3 15, 13 is equal to, so it will give, when you will calculate, this will give 23.4 degrees Celsius. Now take any one of these, 50,000 divided by 3600 kg per second into 4.2 into 1000 joule per kg Kelvin into 695 minus 65 is 30 is equal to U is 2270. You need to find area into 23.4. When you will solve, area will be 32.9 meter square. Effectiveness. We know that effectiveness is equal to Q actual upon Q maximum. So Q actual is equal to what could be mCp delta T of hot fluid divided by C minimum TH1 minus TC1 is equal to mCp delta T of cold fluid. This will remain same. C minimum TH1 minus TC1, where C minimum is the product of M into Cp, and in this case mCp is same, so C minimum will be same. So if you will take any of these two, either this or this for effectiveness, so C effectiveness will be, if I take this formula, then mCp is equal to C minimum both, so del T of hot fluid, that will cancel out, mCp is same, and C minimum is the M into Cp, that is also same, so TH1 minus TC1. Okay, so del T is 95 minus 65, that is 30, and TH1 is 95 minus TC1 is 30, so this will give 65. It will give effectiveness 0.46. Okay, so if you have any kind of doubt, just comment it. Okay, a control system shown below, this is the control system. Determine the variation of y with respect y with time for a step change in set point x and find offset. Okay, so very first thing, we have to find the y upon x. Very simple. 2 1 plus s into 1 upon s plus 4 divided by, this is plus, this is minus, this is plus, this is plus. Okay, so if this is minus in the figure, it is minus. I am not taking it by myself, it is in the diagram. Okay, this is minus, so 1 plus 2 1 plus s plus 4. If in the diagram it is plus, then this become minus, this become minus, but in the diagram it is minus. Okay, so 2 1 plus s upon s plus 4 s plus 4 plus 2 1 plus s upon s plus 4. S plus 4 s plus 4 will cancel out to 1 plus s s plus 2s 3s plus 6 3s plus 6. So this will be the transfer function. Now offset is, we know that offset is equal to x infinite minus y infinite. So x infinite will be s into 1 upon s, because unit step change in the set point. So xt is equal to 1, so xs is equal to 1 upon s at t tend to infinity, s tend to 0, final value theorem. So and s into fs will be this minus s into 1 upon s into 2 1 plus s by 3s plus 6. So this cancel, this cancel, this will be 1 minus 2 by 6 1 by 3. So offset is equal to 2 by 3. So this is the offset. Okay, so if you have any kind of doubt, just comment it. A control system shown below using route test determine the value of kc. Okay, so route array, will be for open loop 1 plus gs is equal to 0. That is the characteristic equation. Okay, this is the characteristic equation. So 1 plus kc s plus 2 by s into 1 upon 2s square plus s plus 1 is equal to 0. When you will solve this, you will get 2s cube plus s square plus 1 plus kc s plus 2 kc is equal to 0. Route array s cube s square s1 s0. So 2 1 1 plus kc and 2 kc. Now suppose it is equal to a, so a is equal to 1 into 1 plus kc, that is this into this minus this into this, opposite to the matrix. In the matrix we do this to this and minus this to this, but in the route array we will do opposite, minus 4 kc upon 1. It will be equal to 0, because route array is saying that any element in the first column of the route array, if 0 or non-negative, 0 or negative, then the system is unstable. So to find the value of kc, we have to put this term equal to 0. So 1 plus kc minus kc 4 kc is equal to 0. So 1 is equal to 3 kc, kc is equal to 1 by 3. Okay, so kc is equal to 1 by 3. Next question. The open loop transfer function of a process is this, where time constant is in minute. Time constant, not times constant, time constant. Determine crossover figure ultimate gain. Okay, so we know that k ultimate is equal to 1 upon amplitude ratio. Okay, so taking amplitude ratio of the process will be 1 upon 4, since it is a first order process. This is bracket weight. So this is 4 under root tau square 9 omega square plus 1 to the power 4. So this is amplitude ratio of the process given. Okay, now we have to find the omega crossover. Okay, because we need to find amplitude ratio to put the value of amplitude ratio here, but omega crossover, then take phase. So phi is equal to minus 4 10 inverse 3 omega. Now at omega is equal to omega crossover, phi is equal to minus 180. Okay, so minus 180 degree is equal to minus 4 tan inverse 3 omega crossover. So this 445 1045, 10 will come this side, it's equal to 3 omega crossover. So omega crossover is equal to 1 by 3. Now put the value here, 1 by 4 under root 9 into omega square 1 by 9, so it will become 1 plus 1 equal to, okay, so 1 by 4, 2 to the power 4 by 2, 2, so 1 by 60. So this is the amplitude ratio and should be less than 1 for stable system. Now put the value here, so ultimate gain will be 60. Okay, so if you have any kind of doubt, just comment it. For a chemical plant, this question is important. If you don't know the flow tree, cash flow tree, then just go and read that. And I haven't told you the book about chemical plant design economics, so it is Max S. Peter Timberhouse. Max and Timberhouse. Okay, Max and Timberhouse, that is a very good book. Okay, so for a chemical plant, the fixed capital investment is this. So FCI is this. FCI is equal to rupees 4 into 10 ki power 9, and working capital is equal to 20%, okay, of the TCI. We know that TCI is equal to FCI plus WC. So FCI plus WC is 0.2 of TCI. So TCI, so 0.8 TCI is equal to FCI. So TCI is equal to FCI by 8. FCI is 4 into 10 ki power 9 by 0.8. 8 5 ja 40. So 5 into 10 ki power 9 rupees is total capital investment. Okay. Okay. Now, okay, the annual total product cost is itna and annual depreciation is this much. If the total annual sales is this, so total sales in a year, total sales in a year is equal to rupees 3 into 10 ki power 9, and income tax is 20%. Determine the percentage of TCI return annually as gross profit. Okay, so very first thing we will see that how much gross profit is coming. So very first thing, in a year we are getting this much of sales minus, so profit after product cost. Profit after product cost will be 3 into 10 ki power 9 minus 2 into 10 ki power 9. So that is 10 ki power 9. Profit after depreciation will be equal to 10 ki power 9 minus depreciation is 2 into 10 ki power 8, 0.2 into 10 ki power 9. Okay, so 0.8 into 10 ki power 9 is remaining. Now profit after income tax, income tax is 20%, so 0.8 will be remaining. 0.8 into 0.8 into 10 ki power 9, this much profit will be profit after tax. Now gross profit, that is the profit which will come after cutting everything. Gross profit is equal to 0.8 into 0.8 into 10 ki power 9 plus depreciation. Depreciation is 2 into 10 ki power 0.2 into 10 ki power 9. So it will give This is 0.64, 0.64 and plus 0.2, 0.84, 0.84 into 10 की power 9. That is the gross profit coming after cutting all the taxes, depreciation, everything. Now, question is asking percentage of TCI return annually. So 0.84 into 10 की power 9 divided by TCI is 5 into 10 की power 9. So 0.85, 0.84 divided by 5. 0.84 divided by 5. 16.8% into 100. 16.8%. Okay. Second, payout time. So we know that payout time, straight formula is there. Payout or pay back is equal to depreciable FCI divided by average profit per year plus average depreciation per year. So depreciable FCI is 4 into 10 की power 9. Depreciable average profit per year, we just have calculated. This is 0.89 into 10 की power 9 plus average depreciation 0.2 into 10 की power 9. So 10 की power 9 2 into 10 की power 0.20. Okay, so this will be 4 divided by 0.84 plus 0.2, 1.04 into 4, 3.84. So 3.84 years, okay, will be the payout period. So if you have any kind of doubt, just comment it below. This question will you will get understand after knowing what is cash reflow, and refer Timberhorse Max for this cash reflow. Okay, this is also an important question, and the same type of question GATE 2019 had asked. Okay, IT Madras, I think. A sphere made up of stainless steel of thermal conductivity. Okay, so we have a sphere, okay, thermal conductivity 16, having a diameter of 40 mm, is exposed to environment of 20 degrees Celsius. So this is 20 degrees Celsius. Okay, and convective heat transfer H is equal to 15 watt per meter square Kelvin. Heat is generated uniformly 1 megawatt per meter cube. Calculate the steady state temperature of the center of the sphere. So center of the sphere. Okay, so very first thing, this is the steady state temperature. Okay, this steady temperature, so the process is steady state. Okay, so applying unsteady state equation for a sphere with internal heat generation. Okay, what is the equation? R square d by d, sorry, 1 upon r square d by dr, r square dt by dr plus q by k is equal to 1 upon alpha dt by dt. This equation is the unsteady state equation for a sphere with internal heat generation. If in the question it is saying that for the cylinder, then instead of r square, r will come, only r will come. Okay, and direct formula GATE 2017 for 1 marks. GATE 2017 IIT Roorkee had asked this formula. Okay, for 1 marks, where you have to find the value of 1 or 2 for sphere or cylinder. Okay, so we will apply this, but the system is steady state, so dt by dt will become 0. Okay, so what else is remaining? 1 upon r square d by dr, r square dt by dr. This is the temperature, small t is the time, is equal to minus q by k, where q is the internal heat generation, that is 1 megawatt per meter cube, k is the conductivity. Now if I will take this r at this side, so it become r is either here and this dr here. Okay, and now integrating this. Okay, so integration of dx is x, so this will come r square dt by dr is equal to minus q by k r cube by 3 plus c1. Okay, now I am taking this dr here and this r square here. So if I will divide this r square, so this become r, this become r square. Now integrating it again, so t is equal to minus q r square by 6k minus c1 by r plus c2. Now what is the boundary condition? At r equal to 0, t is equal to t center, which is equal to t max, and at r equal to r at the radius, t is equal to t surface, right? This is the r, this is t surface, this is t center or t max. Okay, now putting r equal to 0, when I will put r equal to 0 here, this become t center or t max, so I will t center, I will write t center, so this will become 0 minus. Now this term is important, c1 by r square. If I will put r equal to 0, then this whole term become infinity, then the whole complete term will become infinity. So for this term only, r will not be equal to 0, only c1 will be equal to 0. Okay, so this will become 0 plus c2, so c2 is equal to t center, c2 is equal to t center. Now if I will put r equal to r, so t surface is equal to minus q r square upon 6k plus t center. We have to calculate t center, so t center will be ts plus minus q r square by 6k is equal to t center. Now q we have 1 megawatt per meter cube, r we have diameter is 40, so r is equal to 20, and in meter 0.02 meter, so r we have 6 into k we have conductivity, thermal conductivity we have, we don't have ts. Now see from where we will get ts. So q, that is the internal heat generation into the over volume, is equal to h a delta t. Okay, this much is the heat generating that will flow to the surrounding. So 10 की power 6 into volume, when we will multiply with volume, then this meter cube will cancel out. Okay, so volume is for sphere 4 by 3 pi r cube is equal to h, we have area 4 pi r square del t surface minus 20 degrees Celsius, because 20 degrees Celsius we have given. So 4 pi will cut, r square it will only r, so 10 की power 6 into r.02 divided by 3 into h. H is, we have h 15 plus 20, that is ts. So ts will come 464.4 degrees Celsius. Okay, when you will put value here and all the value, you will get T center is equal to 468.6 degrees Celsius. Okay, so if you have any kind of doubt, just comment it below. Okay, this is easy one. It is proposed to reduce the heat loss from a rectangular furnace by doubling its wall thickness shown in the figure. Okay, so very first we have a wall thickness L, then we just make it double to reduce the heat loss. The temperature of the hot surface of the wall is this and this and this. So when we are extending the wall thickness, this temperature will change. Okay, so let's see. So the surface to air. In case 1, the temperature of the outer surface exposed to air is 453. In case 1, estimate the percentage reduction in the heat loss. Okay, so very first thing for this case 1, this is case 1, case 1, case 2. We know that Q is equal to del T upon L upon K is equal to H delta T. Okay, because Q is equal to Q upon A. Okay, so we just multiplied with Q by A and written as Q. Okay, so del T 723 minus 453 divided by L upon K is equal to H, and 453 minus 308. So this is case 1. So from here H L upon K will come 270 by 145. 270 by 145 K upon L. Sorry, 270 by 145 H L upon K. Case second. Q is equal to 723 minus T upon 2L by K is equal to T minus 308 1 upon H. Okay, or H del T, same. So 723 minus T upon 2 is equal to HL upon K, T minus 308. This HL upon K I will multiply as 270 by 145. So you will get T is equal to 395.8 Kelvin. Okay, now percentage reduction. So case first में कितना हो रहा है? You can take either of the value, either this or this. So it will 270 K upon L minus case 2 में you can take either of this. So T minus 395.8 minus 308. Sorry, if I have taken this one, then I will take this. So it will be 723 minus 395 divided by 2 K upon L. So it will give 163.6 K upon L divided by 270 K upon L. So K upon L, K upon L and K upon L. It will give the value of 39.4%. Okay. So this is all, guys. We have completed 1997 all the questions, and I have left few question intentionally because they are out of course right now, and since the gate is asking only for 1 mark and 2 marks, so they will not go so much deep and wide, and they will not give so many lengthy questions. Okay, so whatever is important as a question and as a concept, I have discussed everything. So we'll by November we will complete all the subjective questions. Okay, so if you have any kind of doubt, so just comment it. Okay, bye guys, take care.